Good morning, all of you. Welcome to Sri Jayendra Bank Zone. So far, we have completed lecture 1 in chemical equilibrium. Now we are going to discuss lecture 2 in chemical equilibrium, that is questions based on equilibrium constant. In lecture 1, we have completed only theory part. Now we are going to do numerical part of this topic. So listen carefully. All the numericals are very important because from this concept, you are going to get numericals only. That is equilibrium constant and the factors affecting equilibrium constant, as well as Kp and Kc problems. Let us see now. Yes, example 1. The following concentrations were obtained. The following concentrations were obtained for the formation of ammonia from nitrogen and hydrogen at equilibrium at 500 kelvins. They have given the temperature also. The concentration of nitrogen is given 1.5 in 10 to the power of minus 2 molarity. Concentration of hydrogen is given 3 in 10 to the power of minus 2 molarity. And ammonia, concentration of ammonia is given as 1.2 in 10 to the power of minus 2 molarity. Calculate the equilibrium constant for the reaction for the formation of ammonia, that is N2 plus 3H2 gives us to 2NH3. So it is very, very simple. Since already we know potassium, so that is equilibrium constant is equal to concentration of products rise to the powers of the stoichiometric coefficients, that is, let us say it is X, and concentration of reactants rise to the powers of the stoichiometric coefficient, that is Y. Let us example. So in this case, the products are ammonia and the reactants are nitrogen and hydrogen. So how to find this question? Just see here now. So Kc is equal, because they're asking potassium, they're asking equilibrium constant. They're asking equilibrium constant for the formation of ammonia. So Kc is equal to concentration of ammonia whole square, because 2 moles of ammonia is given, by concentration of nitrogen, that is reactant, it is 1 mole only, and into concentration of hydrogen gas taken thrice. So because it is 3 moles. So after substituting these values, you will definitely get the answer. Let us see the answer now. Answer is given 0.035 10 to the power of 4. So let us see the calculation now. So this is important. So please note down in your classwork. Since this is getting equilibrium constant, Kc is equal to concentration of products raised to the power of raised to the stoichiometric coefficient by concentration of reactant raised to the power of stoichiometric coefficients of the reactants. So here the reactants, 2 reactants are there. One reactant is nitrogen, another reactant is hydrogen. Since for hydrogen it is given 3 moles for the balanced chemical equation. If the equation is not balanced, also you have to do balancing. So as hydrogen is having 3 moles, so whole cube you'll get, and these concentrations of ammonia, nitrogen, and hydrogen is given already. So concentration of ammonia is 1.2 10 to the power minus 2. Concentration of nitrogen is 1.5 10 to the power minus 2, and concentration of hydrogen is 3 to 10 to the power minus 2 molarity. So as the concentrations of the reactants and products are given, so it's a straight question. Simply you have to substitute based on the chemical equation, and after substituting you'll definitely get the answer. So let us see now. So please note down in your classwork. Now let us see this solution also we have made in the PPT, so you can see the solution clearly. So since Kc is equal to concentration of ammonia whole square into concentration of nitrogen into concentration of hydrogen whole cube, we have got this answer. So straight away we can write the answer like this. So if you substitute the values and do calculation, you'll get the answer. So if you want, you can see the previous slide. So this is the answer. Next question number 2. Concentrations of two reactants A and B are zero point 0.8 moles per liter each. This model is very important. They'll ask this type of questions in the entrance exams. Concentrations of two reactants A and B are zero point 0.8 moles per liter each. On mixing the two reactants, the reaction sets in at a slow rate from C to D. According to the equation, A plus B gives rise to C plus D, reversible reaction. And at equilibrium, the concentration of C was found to be zero point 0.6 moles per liter. Calculate the equilibrium constant. So they're asking us to find equilibrium constant Kc. Kc is equal to how much? So for this reaction, you can see here, A plus B gives rise to C plus D. So already we know initial concentration of A is zero point 0.8 moles per liter. That is molarity only. And concentration of B is zero point 0.8. And there is no initial concentration of C and D because these are products. And at equilibrium, you can write here at equilibrium, A becomes zero point 0.8 minus alpha. That is, and B becomes this, we can write it as X. I'll write it clearly. 0.8 minus X, and B becomes zero point 0.8 minus X, and C becomes X moles, and D becomes X moles. So how many moles it is formed? Since X is given, since X is equal to, they have given 0.6 moles per liter. So we can write the equilibrium concentrations of A is 0.8 minus 6. So I'll write it clearly. So the equilibrium concentrations is equal to zero point 0.8 minus 0.6, 0.8 minus 0.6 for reactants, and zero point 0.6 and 0.6 for products. So it is 0.8 minus 0.6 is 0.2. This is also 0.2, and this becomes 0.6, 0.6. Now we already got the concentrations. So straight away, since we already got the concentrations, we can write straight away Kc is equal to concentration of C into concentration of D by concentration of A into concentration of B, because all are 1 mole each. So by substituting this formula, you will get it as 0.6 into 0.6 by 0.2 into 0.2. 0.6, because concentration of C is given 0.6, and automatically concentration of D also becomes 0.6 because they are 1 mole each, and this becomes 0.2 into 0.2. So if you substitute that, you will get the answer 9. So this is the question and these are the solutions. So let us see the solution. Again, I have given the next page. So you can see here clearly. So concentration of A, initial concentration is 0.8, 0.8. Initial concentration is 0, because initially there is no formation of words. Initial concentration of words will be always 0. Initial concentration of products is always 0. And after that certain time of interval. So then how we got is 0.2, because 0.8 minus 0.6 is equal to 0.2. So for both A and B, we'll be getting 0.2. And for C and D, we got 0.6, because after attaining equilibrium, it was noticed that the concentration of C is 0.6 moles per liter. Since the concentration of C is equal to 0.6 moles per liter, so automatically D also becomes 0.6 moles per liter. So because it is only one time 1 1, so by this we can say Kc is equal to 0.6 into 0.6 by 0.2 into 0.2. It is equal to 9, because 3 into 3, 9. I hope it is clear. Next question. Example 3. 2 moles of hydrogen iodide. 2 moles of hydrogen iodide were heated in a sealed tube at 440 degrees C till the equilibrium state was reached. It was found to be 20% dissociated. Here, very, very important. 20% dissociated means percentage of dissociation is only 20%. So that is alpha. Alpha is equal to calculate the equilibrium constant for the dissociation reaction. So we need to find equilibrium constant Kc is equal to how much. So 2 moles of hydrogen iodide were heated in a sealed tube at 440 degrees C till the equilibrium state was reached. It was found to be 20% dissociated. So simply we can write the equation as 2 moles of hydrogen iodide on heating forms 1 mole of hydrogen gas plus 1 mole of iodine gas. Since this is the reaction, reversible reaction they have given, so 2 moles of hydrogen iodide, it was found to be equilibrium state was reached. And initially you can take like this. So 2 moles, 0 and 0, because this is 2 moles, this is 0, and out of 2 moles, only 20% is dissociated. So alpha is equal to 20% dissociation means what? 20% dissociation means alpha is equal to alpha is equal to 0.2, that is 20 by 100. So now we need to find the equilibrium concentration, equilibrium constant. Let us take initially it is 2 moles. This is 0 and this is 0. And at equilibrium it becomes 2 minus alpha. This becomes alpha and this becomes alpha. So like this you have to consideration. You have to do consideration 0.2. Alpha is given 20% only. So 0.2, 0.2. So definitely you'll get. So just copy it on this. Next page I'll give you the solution clearly because we don't have space so that you will not understand properly. So next page I'm giving the solutions clear in the next PPT. So just note it down. I'll wait for you to copy. So initially it is 2 moles of hydrogen iodide as it is given 2 moles. So straight away you can write 1 also. So 0 and 0, 2 minus alpha. So 20% dissociation, alpha is equal to 0.2. They have given because it is 20%. 20% means 20 by 100, which is equal to 0.2. So let us see now the solution for this as I have given it clearly in the next page. See here, 2 minus 0.4. Actually, we should write 2 minus 2 alpha. Here I'll write the equation. Since 2 moles of hydrogen iodide changes to hydrogen plus iodine. I'm writing clearly, please note it down. Since initially it is given 2 moles, so we should write 2 because even if it is not given also, you can expect it is 2 moles. It is 0, that is initially. Now at equilibrium, what happens? This becomes 2 minus 2 alpha, this becomes alpha, and this becomes alpha. This is at equilibrium, because since it is 2 moles, we have to write 2 minus 2 alpha. In the previous slide, I have written 2 minus alpha, so please change it. This is also 2 moles. So 2 minus 2 alpha. Since alpha is equal to 20%, 20% means 20 by 100, which is equal to 0.2. Since alpha is equal to 0.2, so we can write 2 minus 2 alpha, that is equal to 2 minus 0.2 into 2, that is 2 minus 0.4, 0.2 and 0.2. So now we got this is 2 minus 0.4 is 1.6 and this is 2 moles, so we have to take square. So Kc is equal to, for this reaction, concentration of parts. What are the parts we have? Concentration of hydrogen into concentration of iodine divided by concentration of hydrogen iodide square. So if you substitute this, definitely you'll get the answer. So concentration of hydrogen is we already got because it is equal to alpha 0.2 into concentration of iodine. It is also equal to alpha. It is also equal to 0.2 divided by concentration of hydrogen iodide square. It is 1.6 whole square. So after substituting this, you'll get the answer 0.0156. In this way, you are supposed to do. So if it is 1 mole, so you have to take 1, 0, 0. As it is given 2 moles, so because 2 moles of hydrogen iodide, So anyway, for balancing equation, we have to write 2 moles. So 2 minus 2 alpha. 2 minus 2 alpha. If you take 1 mole, 1 minus alpha. And this becomes alpha and alpha, where alpha is called degree of dissociation. Alpha is called what? Degree of dissociation. How much it is dissociated, we have to write. So alpha is called degree of dissociated. So at equilibrium, definitely this step is very, very important. Suppose here 2 is there, then it becomes 2 alpha. And here also 2 is there, it becomes 2 alpha. Suppose here 1 is there, half is there, half half alpha, 1 by 2 alpha. So depending on the number of stoichiometric coefficients, that much alpha will be formed. Depending on the number of moles, that many moles of alpha is formed. Since it is 1 mole, so 1 mole of alpha. 1 mole of alpha is formed. So this is the question number 2. This type of questions are important. So because it is based on degree of dissociation. Degree of dissociation. So it is 20 by 100. It is equal to 0.2. Next question. Equilibrium constants are depends on stoichiometry of the reaction. Very, very important. Equilibrium constant depends upon the stoichiometry of the reaction. So if a chemical reaction is taking place in more than one step, here it is most important, this type of questions. If a chemical reaction is taking place in more than one step, then the overall equilibrium constant is the product of equilibrium constants of individual steps. So how to understand this? For example, let us say A to B. A to B is, let us say it is equilibrium constant K1. Next, B to C. Consider reaction. Let us say equilibrium constant for this is K2. Then A to C becomes A to C. Overall step is A to C, for example, is equal to K is equal to K1 into K2. K1 into K2. So this is called K1 into K2. So this is nothing but the overall equilibrium constant Kc is equal to K1 into K2. That is the product of equilibrium constants of individual steps. So this is clear. So A changes to B, B changes to C. So if A changes to B is equilibrium constant for this reaction, equilibrium constant for this reaction is K1. Then B changes to C. Suppose let us say equilibrium constant for this reaction is K2. Then A changes to C, that is overall step is equal to K is equal to, that is Kc is equal to K1 into K2. That is nothing but the product of equilibrium constants of individual steps. Product of equilibrium constants of individual steps. So this type of questions are most important. Definitely you get in the examination. Let us see the explanation also given in the next PPT. So example 1, you can see A changes to B. A is gas, B is gas. Let us say the equilibrium constant for this step is K1 and B changes to C. Let us say the equilibrium constant for this step is K2. Adding now for the overall reaction, how to calculate equilibrium constant K3 is equal to K1 into K2. So the two reactions having equilibrium constants K1 and K2, if reaction is reversed and add to the reaction. So this is condition number 1. Now next condition, you see this condition is also very, very important. Definitely they are going to ask questions based on these conditions only in the entrance exams. Suppose if two reactions having equilibrium constants K1 and K2, and if the reaction is reversed and added to the reaction, the equilibrium constant for the resultant reaction is K3 is equal to K2 by K1. So if they are adding reverse means what? For example, in the same reaction, if they are asking equilibrium constant for C to A, then K3 is equal to K2 by K1. Instead of asking A to C, overall reaction, if they ask for C to A, for the same above reaction, if they ask for, write the equilibrium constant for the reaction C to A, then we have to use the formula C to A is equal to, that is nothing but A becomes product and C becomes reactant. So the reaction becomes K2 by K1, K2 by K1. So this condition is also very, very important. Please note it down in your classwork. See example 2. Consider reaction products P gives us to R plus C, it is K1, and A plus B gives us to C, that is K2. So here the product is C and here the product is C. And A plus B plus R is equal to P, that is K3. then K3 is equal to K2 by K1. K3 is equal to K2 by K1. So if a chemical reaction is having equilibrium constants K1 multiplied by a factor of N, then the resulting equation, this is next concentration. So this question you can see here, please clearly see. Example 2, suppose P gives rise to R plus C. This is the K1. And formation of P is given, formation of C is given, K2 and K3. Then by this we can say K3 is equal to K2 by K1. How it is possible, you can just see here. K3 is what? So K3 is equal to, I'll show you. K3 is equal to concentration of parts, that is P, by concentration of reactant, that is concentration of A into concentration of B into concentration of R. So let us see here, K3 is equal to this K2 by K1. Let us take K2. K2 is equal to concentration of C, that is products by concentration of A into concentration of B, divided by K2 by K1. K1 also I write here, divided by K1. K1 is how much? Concentration of C by into concentration of R by concentration of P. So if we divide these two, what is the answer you'll get? C and C gets cancelled. RAB will become AB into R, and this CP will go to numerator. So like this you'll get. Just you have to substitute the formula wise. Next condition, this is also important condition. Next condition number 3, if a chemical reaction is having equilibrium constants K1 is multiplied by a factor of N, then the resulting equation has equilibrium constant K2 is equal to K1 whole to the power of N, because number of times, where N can be a fraction, it can be a fraction also. It can be a fraction. Let us see the example for this. Consider A2 plus B2 gives us 2AB. For this reaction, the equilibrium constant is K1 for the first reaction. Next, second reaction, half A2 plus half B2 gives us to K2. Then what is the relation between K2 and K1? So it is 1 mole, 2 moles, and it is half mole, and 1 mole. So definitely we can say K2 is equal to K1 whole to the power 1 by 2. That is nothing but root of K1, because K2 is equal to K1 to the power 1 by 2. How? You can just see here. Since K2 is equal to, what is the K2 formula? Now K2 is equal to concentration of, this is actually they should give AB. Here we forgot to give AB. So concentration of AB divided by concentration of A2 to the power 1 by 2 and concentration of B2 to the power 1 by 2 is exactly 2 times of K1. So that's why you can say K2 is equal to K1 whole to the power of 1 by 2. So that is nothing but root K1. K2 is equal to root K1. Like these questions are very, very important. Definitely you have to compare and then you have to solve the questions. It is easy also if you do it properly. So please copy down in your classwork. Next. Now questions based on this. Given that at 1000 kelvins, 2 moles of sulfur dioxide, 1 mole of oxygen gives 2 moles of sulfur trioxide. K is equal to 261. K is equal to 261. That is, calculate K for the following equations. Here they are given K is Kc value. So it is 261. Now let us see. Calculate Kc for this equation. This is SO3. This is reverse of this. Sulfur trioxide gives rise to sulfur dioxide plus half O2. 2 moles of sulfur trioxide, 2 moles of sulfur dioxide, 1 mole of oxygen. Just reverse of this. And this is equal to SO2 plus half O2 gives rise to SO3. So just for our understanding, I'll write here. Since for this reaction K is given, so K value. So for this, let us say this is K1, this is K2, and this is K3. So by this you can say K1 is equal to SO3, reverse of this reaction with half moles, because half and this is 2 moles. Here sulfur trioxide is 2 moles, but here we are given only 1 mole. So, and sulfur dioxide is 2 moles, but here 1 mole. And oxygen is 1 mole and it is given half mole. So straight away we can write, so let us say this is K. So K1 is equal to 1 by root K, 1 by root K. And next we have K, second equation, 2SO3, 2SO2 plus half O2. So K2 is equal to, since number of moles are same, 2 moles of sulfur trioxide, 2 moles of sulfur dioxide, 1 mole of oxygen. So by this easily we can say K2 is equal to 1 by K, but because it is reversible reaction. So reverse of this, so 1 by K with respect to K I'm writing. So next K3, SO2 plus half O2 gives us to SO3. So it is again same reaction, straight reaction, but with half mole. So K3 is equal to root K, root of K. So this is the question now. So K3 is equal to root of K. And this value of K is not printed clearly. So this you can understand easily. So since the reaction is 2SO3 changes to as O2 plus 2SO2, but the reaction is here, reverse is given. So that's why, and even half moles, half of the first reaction, half of the given reaction. Since it is half of the given reaction, we can say K1 is equal to 1 by root K. And this is equal to given reaction but reverse, so K2 is equal to 1 by K, and this is equal to given reaction only with half moles, that too in forward direction only, same reaction but with half times. So straight away we can see K3 is equal to root K. So simply if you substitute this formula, directly you'll get the answer. Next question, same question, I'll give you here explanation also, calculation part also I have done. You can just see here now. So K1 is equal to 1 by root K, it is equal to 0.06189, and K2 is equal to 1 by K, it is 3.8314 into 10 point, 10 power minus 3. Sorry. And K3 is equal to root K, that is equal to 16.155. That is root of 2.261. So this is the answer. Is it clear? Next question. The equilibrium constant of the reaction hydrogen plus iodine gas to form 2 moles of hydrogen iodide at 426 degrees C is 55.3. Means for this reaction they are given Kc value. What will be the value of equilibrium constant if the reaction is reversed? Reversed means nothing but 1 by 55.3. Straight away we can get. And if the given reaction is represented as 3 moles of hydrogen, 3 moles of iodine, and it gives us 6 moles of hydrogen iodide. So it is 3 times. It is nothing but what? 3 times. That is 555.3 whole cube we have tried. Because simple it is. Because 1 mole, 2 moles. So 3 moles, 3 moles, 6 moles. So automatically it is increased by how many times? 3 times. Since it is increased by 3 times, we have to make 55.3 whole cube. 55.3 whole cube. So in the first case, Kc is equal to, that is K1 is equal to, first reaction K1 is equal to 1 by Kc. Straight away we can write 1 by Kc, because only if the reaction is reversed they are asking. Same reaction reversed. That is 2 moles of hydrogen iodide will come as reactant, and hydrogen and iodine gas has come as products. Since hydrogen and iodine gas has come to products, so automatically it is K1 is equal to 1 by Kc. And K2 is equal to, for this reaction, K2 is equal to 3 times of Kc, because if the reaction is represented as 3 moles of same reaction, no reversing, but here we have to write, so Kc, that is Kc whole to the power of 3, because 3 moles, 6 moles. So 1, 1, 2, so we have to take K2 is equal to Kc whole cube. K2 is equal to Kc whole cube. So in this way, if you do, you'll get the answer. So that is 1 by 55.3. 1 by 55.3 is 0.018. And 55.3 whole cube is equal to 1.69 10 to the power 5. You can multiply it and you can convert that in 10 in terms of tens power. Even this solution also I have given it clearly. The second slide, next slide, you can see here. So K is equal to 1 by Kc. It is equal to 0.018, and K is equal to Kc whole cube. It is equal to 1.69 10 to the power 5. Kc means how much? 55.3 whole cube is equal to nothing but 55.3 because Kc value is also given. Simply they'll give temperature, so it has no effect on temperature. So 55.3 whole cube, it is equal to 1.69 10 to the power 5. And this is 1 by 55.3. 1 by 55.3 is equal to 0.018. So you can do the calculation. So this type of questions are most important for the examination, entrance exams. Definitely they'll ask this type of questions because it's comparison of Kc with respect to other equations, comparison of equilibrium constant with respect to other equations. So definitely you are going to get this type of questions. So please note it down, all the important models. So with this, I'm stopping this lecture. So after this, we'll continue with the new concept in potash, that is Kp and Kc. So more questions we'll do it on more questions on Kp and Kc. We'll do it in the next session. So you have to follow what we have discussed clearly. It is very, very important. Thank you all.